Okay, here we go on question number 44. What is the most efficient way to solve the stated system? So the most efficient way, well, it's already set up. Both of them are set up in standard form, and the 2x, and I have a negative 2x. So elimination is the most efficient way. Most efficient. What is the most efficient way to solve this stated system? Well, this is in standard form. This is in y equals form now. So y, it's already solved. I would substitute it in. Most efficient would be substitution right there. Okay. 45. Check which of the following ordered pairs represents a solution to the system of equations. Select all that apply. So remember, solutions have to be true in both. So for choice A, I have to plug -1 in here. So do I get -1 equals 2 plus 3? I get -1 equals 5. Not true. I don't have to go any further. Okay? Let's try B. 2 and -1. So this is 2, -1. So when I plug that in here, I get 2 equals -1 plus 3. 2 equals 2. That checks. Got to check it in that bottom equation. So I get 2 times 2 minus 2 times a -1 equals 6. And let's see what this is. This is going to be 4 minus -2 times there is a +2. So 6 equals 6. So this one checks. So this is a solution. Choice C, 0, -3. Let's see if this works. When I plug it in here, I get 0 equals -3 plus 3. 0 equals 3. Or 0 equals 0. Sorry, that checks. Does it check in the bottom part? So 2 times 0 minus 2 times a -3 equals 6. So what do we do here? Whoops, this is a +3. Sorry. So when we get here, we don't need that. This is a 6. Does not check. Can't be a solution. So that one can't. What about choice D? We get 3, 0. So I get 3 equals 0 plus 3. 3 equals 3. Checks. In the bottom equation, I get 2 times 3 minus 2 times 0 equals 6. 2 times 0 is 0. 2 times 3 is 6. So 6 minus 0 is 6. 6 equals 6. That checks. So B and D. Just got to plug them in. Okay? Question number B now. Let's do the same thing. So I'm going to check. Whoops. I'm going to check 0 and 2. Choice A. So choice A. When I check 0 and 2, I get -3 times 0 plus 6 times 2 equals 12. This is 0, so 12 equals 12. That's good. Let's put it into the next one. So I get 0 minus 2 times 2, whoops, equals -4. This is a -4 equals -4. That checks. First choice is good. Let's try choice B, which is 3, 4. Sorry. So when I plug it into the first one, I'm going to plug in this bottom one first, see if it checks. Looks like it's a little bit easier. So let's say 3 minus 2 times 4 equals -4. 3 minus 8 equals -4. I get -5 equals -4. Not good. Can't check that. That's not a solution. So choice C is 4. Let's plug in that bottom one again. It seems easier. 4 minus 2 times 4 equals -4. So I get 4 minus 8 equals -4. 4 minus 8 is a -4 equals -4. That checks. So now we got to plug it in the top part. So I get -3 times 4. That's a -12. 6 times 4 is a +24 equals 12. Negative 12 plus 12, 24 is a positive 12, so 12 equals 12. That's good. So choice C is a good one. Running out of room here. So we'll try D. Negative 6, negative 1. I guess we can just start right from the top. So negative 6 times negative 3 is a positive 18. And then 6 times negative 1 is a minus 6. Equals 12. 18 minus 6, 12 equals 12. That's good. Plug it in the bottom. I get negative 6 minus 2 times a negative 1 equals negative 4. So negative 6 plus 2 equals negative 4. Negative 2 times negative 1 is a positive 2. I get negative 4 equals negative 4. That checks. So A, C, and D are the answers. We just need to plug those in to see how they work. Okay, 46. Which of the following is not a representation of this system? So this system, remember, we can multiply a number through and make just a multiple of the equation. It's the same equation. So how do I compare this to this? It looks like that bottom equation is the same, and the top equation, 2x minus 2y. Well, how would I make this that? I could multiply this by 2, right? So I'd get 2x minus 2y equals 4. That is a representation, so it's not an answer. Okay? What about here? Well, that bottom equation is the same. How did they change this top one? Well, this x is positive, this is negative. So looks like they'd have to multiply by negative 1 up here. So we'll multiply by negative 1, negative x. That's what they have. Plus y. Okay, multiply by negative 1. And minus 2. So that is a representation. You're just multiplying by negative 1. So not a representation. Okay? Bottom equation is the same. How did they change this top? Well, this is x plus y equals 2. This is x minus y equals 2. Well, they didn't change the x, but they just changed the y. They can't just do that. This is not a representation. Right there, that's the difference. Okay? They'd have to change this sign and this sign also if they're changing that middle sign. Let's double check this bottom one. Looks like they changed both here. So how would I get from this equation to this? Looks like I can multiply by 2. So multiply by 2, I get 2x minus 2y right there. 4 times, and 2 times 2 is 4. So that's good. Down here, looks like they multiplied by a negative 1. So negative 1 times x is negative x. Negative 1 times y is negative y. Negative 1 times positive 8 is, or negative 8 is a positive 8. So that is a representation. So C is the only answer. Okay? So not a representation again. Let's try and go through this again now. Bottom equation is the same. How can I change this top equation to make this? Well, this, I could just rewrite this as 5x minus y. I just changed that, equals negative 9. Right? So that's the same as that. Bottom equation is the same, so that's not, they just rearranged it. Okay, bottom equation is the same. What can I do to this equation? Well, to get from 5 to 10, I have to multiply by 2. So let's see if it works. 2 times 5x is 10x. 2 times negative y is negative 2y. 2 times negative 9 is negative 18. So that's a representation. We're looking for one that's not. Okay, let's look. I got 5x minus y equals negative 9. That top equation is the same. Down here, well, they changed this to a 2y, so I'd have to multiply this by 2. So 2 times y is 2y. 2 times 2x is 4x. 2 times 2 is 4. So that's not a representation. So I guess this is the one, but let's make sure. So I got negative 5x plus y equals 9. Well, they multiplied this by a negative 1. Negative 1 times this is negative 5x minus y minus 9. That looks good. What about on the bottom? This is a positive y, negative y. So you have to multiply this by negative 1. Negative 1 times y is negative y. Negative 1 times 2x is a negative 2x. They have a positive. So that's not the one that represents that system. Okay.